Welcome to our deep dive into Python for economics and finance. We're using the book Python Programming for Economics and Finance to see why Python is so important in these fields.
It's interesting how the book gets right to the point. It knows that time is valuable in finance.
Yeah, it doesn't spend time on basic programming. It assumes you're here to use Python for economics and finance.
Exactly, and that's where Anaconda comes in. It's the recommended Python distribution.
The book really emphasizes Anaconda, doesn't it? It says that using Anaconda can prevent a lot of setup problems, especially if you're not a software expert.
Anaconda is like a toolkit specifically for economic and financial analysis. Instead of finding individual tools, you get everything you need. Python, libraries like NumPy, SciPy, and Matplotlib, and even Conda to keep everything organized.
It's like getting a custom-made suit.
Exactly. Efficiency and practicality are important.
And then there are Jupyter notebooks. The book says they can really change how you work. They're more than just for coding.
Jupyter notebooks are like interactive research papers. You can combine code, equations, visualizations, and explanations all in one place. Imagine seeing your economic model change in real time as you adjust it.
It's a huge change for collaboration and being able to reproduce research.
Absolutely. It makes your analysis clear and interactive.
So we have Anaconda and Jupyter notebooks. Now let's look at the basics of Python. The book says libraries are a good place to start.
That's right. Python's power is in its libraries. They're like specialized assistants. Libraries like NumPy are for numerical computation, SciPy has scientific functions, and Matplotlib helps you create visualizations.
The book mentions using functions to write code you can use again.
Yes, don't repeat yourself. Functions are like blueprints. You define them once and use them whenever you need them.
And Python is very flexible with data types, which seems important for economics and finance.
Absolutely. The book covers lists, tuples, sets, and dictionaries, the basics for organizing data in economics and finance.
Being able to read and write text files is essential for real-world data analysis.
Think about all the economic and financial data we have. Stock prices, exchange rates, GDP figures. Python makes it simple to import and analyze this data.
The book then talks about object-oriented programming, which might be new to some people.
It can be a little confusing at first, but it's important for complex projects. Object-oriented programming lets you model real-world things. The book's example of a consumer class shows this. You can define things like wealth, income, and how a consumer spends money.
It's interesting how this kind of programming reflects real economic systems.
Yes. You're creating a digital space to test economic ideas. And that brings us to speed, which is important in finance.
The book says that while Python is user-friendly, it can be slow for complex tasks, like financial modeling.
That's where vectorization and NumPy come in. Vectorization lets you replace slow Python loops with fast array operations using libraries like NumPy.
And NumPy sounds amazing.
NumPy can make your Python code much faster. It compiles your functions to machine code so they run as fast as C or Fortran, which is important for complex models.
So we have these tools, but the book really stresses choosing the right Python distribution.
Yes, and it recommends Anaconda for economics and finance. It's popular, works on different systems, and has lots of scientific libraries.
And Conda sounds like a great package management system.
Conda is essential. It keeps your Python environment organized. It's like a librarian for your code libraries. It makes installing and managing packages easy.
The book seems to be setting us up for what's next, assuming we have Anaconda.
Absolutely. We're being guided towards a streamlined way of working with real economics and finance problems. With your environment set up, let's look closer at Jupyter notebooks. The book really emphasizes that they're super important for data scientists. They can combine code, results, and explanations all in one place.
Like a digital notebook where you can track your whole economic analysis process.
Exactly. The book walks you through how to start a Jupyter notebook using Anaconda Navigator. It's easy to get started.
And the interface is really user-friendly. The book explains the basics, like running cells and switching between code and text. Plus, there's online help, which is great for beginners.
A cool thing about Jupyter notebooks is that you can put regular text, equations, and even interactive visualizations right into your code.
And you can even personalize your workspace. The book talks about using CSS to change things like font sizes.
The book also mentions platforms like Google Colab and Kaggle. They let you work on notebooks with other people.
And for more private projects, the Jupyter Lab real-time collaboration extension lets you work together in the normal Jupyter environment.
Then the book shows you how to install libraries within a Jupyter notebook using Conda. There are examples specific to economics and finance, like installing libraries for quantitative economics.
It's great how the book uses relevant examples.
Remember that even though Jupyter Notebooks are versatile, sometimes you might need to work with normal Python files. The book talks about this briefly, explaining how to use a text editor or an IDE.
That gives you more options.
The book then digs deeper into Python packages, which are basically directories with collections of Python modules. It's important to understand packages so you can organize your code and use external libraries.
It's like a company with different departments. Packages help structure your code.
The book uses NumPy as an example. For instance, np.random is for generating random numbers, and np.linealg is for linear algebra.
It's well organized and helps you find what you need.
Python gives you different ways to import names from these packages.
You can import a whole module or just a specific function.
That lets you tailor your code to exactly what you're doing.
Now let's go back to loops, which are essential for repetitive tasks. The book focuses on the for loop.
The for loop is really flexible. You can use it with lists, tuples, strings, and numbers. The book explains it clearly and emphasizes the importance of indentation in Python.
Indentation is key for organizing your code and avoiding errors.
The book gives examples of how to use for loops for economics and finance, like calculating a bank balance over time.
It shows how a simple loop can be used for financial calculations.
The book then introduces conditional statements, specifically if-else statements.
These are important for making decisions in your code. You can check conditions and execute different code based on the results.
The book explains if-else statements using comparison operators like greater than and less than.
It also gives an example of using an if statement to see if a point is inside a circle.
This shows how you can use conditional statements with math.
Now let's talk about functions in more detail. They're crucial for writing reusable code.
Functions are like mini programs within your main program.
The book starts with built-in functions in Python, the ones you can use right away. These functions handle common tasks.
Then there are functions from other modules or libraries. The book gives an example of using the calendar module to check if a year is a leap year.
It shows how you can expand Python's functionality.
But the most powerful thing is defining your own functions. The book explains how to do this clearly using the def keyword.
The book emphasizes using the return statement to specify what a function should output. It also explains default arguments and keyword arguments, which make functions more flexible.
Python functions are versatile. They can handle a variable number of arguments and can even return multiple values.
These features make them adaptable.
The book gives examples of using functions to generate and plot time series data, a common task in economics and finance.
One example shows how to make code more organized by putting the data generation logic inside a function.
Another example shows how to compute and plot a mathematical series. This uses NumPy arrays for calculations and Matplotlib for visualization.
These examples are great for seeing how functions work in practice.
Now let's talk about data types, the basic elements for organizing information. The book starts with lists.
Lists are flexible. They can hold numbers, strings, and even other lists.
Then the book introduces tuples, which are like lists but can't be changed. This is useful when you need data to stay the same.
Sets are another type. They're unordered and only contain unique elements.
And then there are dictionaries. These are collections of key-value pairs.
The book explains all of these data types well.
Now we come to input and output operations. These are crucial for working with data from outside sources. The book focuses on reading and writing text files.
The book explained how to open a file, write data, and close it. It emphasizes using the with statement to make sure files are handled properly.
The book then shows how to read data from a text file and how to go through each line.
This is important for working with large data sets.
It also covers how to add data to a file without deleting what's already there.
The book then introduces list comprehensions, a concise way to create lists in Python.
These make your code more efficient.
The book also explains the zip function, which combines multiple lists or tuples.
And there's the enumerate function, which gives you both the index and the value of each element.
These are all useful tools.
Now, let's get into object-oriented programming.
The book says that everything in Python is an object. Objects are based on classes, which are like blueprints.
It's a powerful way to organize your code.
The book explains objects in detail, saying they have a type, an identity, data, and methods.
It uses the built-in int type as an example.
This helps understand how objects work.
The book also looks at Boolean data types, which are true or false.
This shows that even simple things are objects in Python.
Let's talk about names and namespaces, which are important for keeping your code organized.
Names in Python refer to objects. They're like labels.
The book explains that when you give a name to a value, you're connecting it to an object in the computer's memory. This is managed by dictionaries called namespaces.
Namespaces are like containers for names, preventing conflicts.
The book gives an example using a script called mathfoo.py that defines a variable called pi. When you import the script, Python creates a namespace for it.
To access pi from that namespace, you would use mathfoo.py.
Then the book explains scope, which determines where names are valid.
Python uses the LEGB rule: local, enclosing, global, built-in.
It's important to understand this so you know which variables you're using.
The book gives a detailed example of how Python finds names in a function.
It's important to note that if you give a name to a value inside a function, it doesn't change the global variable with the same name.
This prevents unexpected problems.
Now, let's move on to building classes.
These are the blueprints for objects.
The book explains how to define classes using the class keyword.
It introduces the constructor, which sets up the object.
Then it walks you through creating a consumer class, showing how to define attributes and methods.
The book clearly explains the purpose of each part.
The self parameter is important because it refers to the current object.
The book gives examples of using the consumer class.
Methods are shared by all objects of the class. Python uses self to make sure the methods work on the correct object.
The book then gives a more complex example of a market class.
This shows how object-oriented programming can model real-world situations.
The book also explains how to add more functionality to classes by defining new methods.
It revisits the market class and shows how to add a method.
And then there's inheritance, which lets you create new classes based on existing ones.
The book gives an example of a demand curve class that inherits from a function class.
Inheritance is great for code reuse.
Now let's talk about writing longer programs with multiple files.
The book discusses development environments. These provide tools for writing, running, testing, and managing your code.
IDEs and text editors can really help.
First, the book introduces JupyterLab, a browser-based environment that's like an enhanced Jupyter notebook.
It supports different file types and has lots of features.
Then the book talks about Visual Studio Code, a popular code editor.
It works with many programming languages and has features like syntax highlighting and debugging tools.
The book shows you how to install the Python extension for VS Code and how to run a Python script interactively.
Let's dive into scientific computing with Python.
Python has become really popular in science because it's easy to use and has a lot of libraries.
The book talks about both the good and bad sides of using Python for scientific work.
It's easy to use, but sometimes it can be slow.
But its libraries make up for this.
The book quickly goes over some important scientific libraries like NumPy, SciPy, Matplotlib, Pandas, and Numba.
These libraries are essential for various scientific tasks.
The book reminds us that while Python is powerful, it's important to know about its limitations and to optimize your code for speed.
So let's talk about speed.
The book explains why Python can be slower than languages like C or Fortran.
This is because Python is interpreted and dynamically typed.
This means the computer has to do more work while the program is running.
But Python tries to make up for this.
For example, Python stores list elements together in memory to make access faster.
But Python's lists still have some overhead.
Minimizing memory traffic is key for speed.
Now let's look at vectorization.
This is about performing operations on whole arrays instead of individual elements.
NumPy is perfect for this.
NumPy uses fast C or Fortran code, making it much quicker.
The book gives examples of how vectorization works.
It compares vectorized code to normal Python loops, showing how much faster it can be.
But the book points out that vectorization isn't always the best solution because it can use a lot of memory.
What are some other ways to speed up Python code?
There's Numba, which compiles your Python functions to machine code.
It's really good for code with lots of loops.
The book introduces Numba's special decorator for JIT compilation.
It shows how to use it and the difference in speed.
Numba figures out the types of variables and uses that to create fast machine code.
It's like getting the best of both worlds.
The book gives various examples of using Numba.
But it's important to use Numba carefully, as it might not always be effective.
Now, let's get into NumPy in more detail.
NumPy's arrays are multidimensional, unlike Python's lists, and they're great for numerical computations.
The book shows you how to create arrays and how to access and change elements.
It emphasizes the importance of understanding array dimensions.
It then explains array methods, which are like built-in functions for arrays.
These make it easy to do calculations and other operations.
Broadcasting is another important feature that lets you work with arrays of different shapes.
It makes your code simpler.
The book explains the rules of broadcasting.
It also talks about vectorized functions and array comparisons.
These are optimized functions that work on entire arrays.
The book encourages you to learn more about NumPy by looking at its documentation.
Next, we have Matplotlib, which is used for creating visualizations.
It can create various plots, from simple to complex.
The book explains the basic ideas of Matplotlib, introducing figure and axis.
Then it shows you how to create a simple line plot.
Customization is key in Matplotlib.
You can add labels, titles, legends, and more.
The book covers various types of plots: scatter plots, bar charts, histograms, 3D plots, and more.
Choosing the right type of plot is important.
You can customize the look of your plots in a lot of ways.
Colors, line styles, markers, and more.
You can also use style sheets for a consistent look.
The book recommends learning more about Matplotlib.
Now, let's move on to SciPy, which builds upon NumPy.
SciPy has modules for optimization, integration, statistics, signal processing, and more.
The book explains how SciPy uses NumPy, but focuses on higher-level scientific routines.
You should still explicitly import NumPy when using SciPy.
The book gives an overview of some key sub-packages within SciPy.
These cover various scientific tasks like optimization, integration, and statistics.
The book suggests looking at the documentation for more details.
Let's talk more about SciPy.stats.
It has a lot of tools for working with statistics.
The book explains the difference between NumPy.random and SciPy.stats.
SciPy.stats is more object-oriented.
It gives an example of using norm to represent a normal distribution.
You can use it to calculate probabilities and generate random samples.
Then the book talks about kernel density estimation, KDE.
KDE is a non-parametric method for estimating the probability density function.
It's versatile because it doesn't assume a specific distribution.
The book gives an example of using KDE with SciPy.stats.
Now let's explore roots and fixed points.
These are important in many areas of economics and finance.
The book discusses the bisection method for finding roots.
The bisection method keeps narrowing an interval until it finds the root.
The book provides a Python implementation of it.
It's important to note that the function must be continuous for the bisection method to work.
Then the book introduces SciPy.optimize, which has more advanced algorithms.
There's also the branch shoe function, which is a good method for finding roots.
The book recommends exploring the different root finding functions in SciPy.optimize.
Now let's move on to optimization.
SciPy.optimize has tools for this too.
The book focuses on two types of optimization: univariate and multivariate.
It introduces im and bound for univariate optimization and minimize for multivariate optimization.
It gives examples of using both functions.
SciPy.optimize can handle both constrained and unconstrained optimization.
Next, we have numerical integration.
SciPy.integrate has functions for this.
The book introduces the quad function, which uses adaptive quadrature.
It also explains Monte Carlo integration, which uses random sampling.
Monte Carlo integration is especially useful for complex integrals.
The book gives an example of using Monte Carlo integration to estimate the price of an option.
Now let's focus on Pandas.
Pandas is great for data analysis and manipulation. Its data frames and series are really useful for working with real-world data.
It can read data from a lot of different sources.
The book first talks about series, which are one-dimensional labeled arrays.
Then it introduces data frames, which are two-dimensional and look like tables.
The book shows how to create a data frame and access its elements.
It then covers working with data frames, selecting data, sorting, handling missing values, and calculations.
And then there's modifying data frames.
Pandas lets you change data within a data frame.
Right.
There's the df.where method for filtering data.
Handling missing values is important.
Pandas has ways to fill in missing values.
Merging and joining data frames are important for combining data.
Pandas has merge and join functions for this.
The book explains different types of merges and gives examples.
Merging is essential for creating data sets from multiple sources.
Grouping and aggregation are powerful techniques for summarizing data.
Pandas has the Group B method for this.
The book gives examples of using Group B to calculate summaries for different groups.
Pandas also lets you create plots directly from data frames.
It integrates with Matplotlib so you can create various types of plots.
The book gives examples and explains how to customize plots.
Now let's talk about online data sources.
Python has libraries for accessing data from FRED, OECD, Eurostat, the World Bank, and more.
The book introduces the requests library for making HTTP requests.
It shows how to use requests to download a CSV file from a website.
Then it explains how to use Pandas to read this data.
Next, the book introduces Pandas Data Reader, which makes it easy to get data from various sources.
It simplifies interacting with APIs.
The book gives an example of downloading data from the World Bank and plotting it.
Then it discusses the EFI Finance library for accessing Yahoo Finance data.
It's a great tool for financial analysis.
The book shows how to use it to download stock prices and calculate returns.
The book recommends exploring the documentation for these libraries. They're great resources for economic and financial data.
Now let's look at how Pandas handles panel data, which is common in economics and finance research.
Panel data needs special tools, and Pandas has them.
The book talks about multi-indexes, which allow for multiple levels of indexing.
This creates a hierarchy for organizing panel data.
The book shows how to create a multi-index and how to access data using the different levels.
It also covers merging data frames with multi-indexes.
It gives examples of using merge to combine these data frames.
You can also use grouping and aggregation with multi-indexes.
The book gives examples of using groupie to calculate statistics for different groups within panel data.
Then it shows how to plot panel data.
It uses Matplotlib to create line plots and Seaborn for box plots.
These examples show how versatile Pandas is for panel data analysis.
Now let's talk about SciPy, which is used for symbolic math.
SciPy lets you do math with symbols instead of numbers.
It can solve equations, simplify expressions, do calculus, and work with matrices.
The book shows you how to install SciPy and make it display expressions nicely.
Then it explains how to create symbols and use them in equations.
The book gives examples of solving different types of equations.
It also covers inequalities and logical expressions.
This lets you work with mathematical relationships in a more abstract way.
Then the book shows you how to do calculus with SciPy, derivatives, integrals, limits, and series expansions.
It has examples of solving calculus problems.
You can also convert symbolic expressions to numerical functions using lambdify.
It gives an example of using this with NumPy.
The book then shows how to use SciPy in economics.
One example is solving for the fixed point in the Solus 1 growth model.
It also shows how to find optimal allocations in a simple economy.
The book encourages you to learn more about SciPy.
Let's move on to high-performance computing.
We'll revisit NumPy for making Python code faster.
It's really useful when speed is essential.
The book shows how to use NumPy's @ngit decorator for JIT compilation.
Then it explains how NumPy works.
It can make Python code almost as fast as C or Fortran.
But it's important to use NumPy strategically.
Parallelization is another technique for speed.
This involves using multiple processors.
It can make a big difference if your task can be split into smaller parts.
The book talks about multiprocessing and multi-threading.
These are two different ways to do parallelization.
Then the book explains how NumPy uses multi-threading.
This can make NumPy faster without you doing anything.
The book shows how to see this multi-threading in action.
It also discusses how to parallelize loops using NumPy.
This can be much faster than a normal loop.
The book emphasizes the benefits of parallelization.
It also mentions JAX, another library for high-performance computing.
It suggests looking at resources specifically about JAX.
Now let's talk about writing good code.
It's not just about making the code work.
The book stresses writing readable code.
It talks about avoiding common mistakes, like using magic numbers.
Magic numbers are just numbers in your code without clear meaning.
It's better to use named constants.
Code repetition is another bad practice.
The book encourages you to follow the DRY principle. Don't repeat yourself.
It gives examples of how to refactor code to make it better.
Now let's look at some more language features that can make your code better.
The book talks about iterables and iterators.
These are about working with sequences of data.
It explains how to use iterators and the operators.
Then there are assertions for checking if something is true.
They help catch errors early.
The book explains assertions and gives examples.
It also covers generators, which produce sequences of values one at a time.
They're good for large data sets.
The book shows how to define and use generators.
Finally, the book talks about debugging and handling errors.
Debugging is finding and fixing errors, while error handling is making sure your program doesn't crash.
It starts with using print statements for debugging.
But it also introduces the Python debugger, PDB.
PDB is a powerful tool.
The book gives examples of using PDB.
Then it explains how to handle errors with try, except blocks.
These help you catch errors and handle them gracefully.
That brings us to the end of our deep dive. You now have a strong foundation in using Python for economics and finance. You've learned how to set up your environment, write efficient code, work with different types of data, and use object-oriented programming. We've seen how Python can bring economic theories to life and how libraries like Pandas help us analyze data. Most importantly, we've emphasized that learning is a continuous process. There's always more to explore with Python, so keep experimenting and pushing your boundaries. This deep dive has given you the tools. Now it's your turn to discover what you can achieve.